And I just want to say hello to all the people joining online as well. We're lovely to have you join us virtually. I really want to hear lots of questions from you in this session, so please enter them in via the app. I think we can go old school in the room. There is a roving mic situation, so please be that person and ask a question. You all know why we're here. So the format of this is going to be, Erica's going to do a brief presentation, and then we want to leave some time for Q&A. So just to get us started, I just want to, in very short order, set the policy context for this. You will hopefully all remember that the Commonwealth and all the states and territories signed up to a trajectory for low energy buildings in 2019. That committed all of those governments to a program of scheduled improvements to the National Construction Code out to 2030. And we've been alternating focus between commercial buildings and residential buildings since that policy framework came into place. So 2019 was the first time in a decade that there was a really big step change in the commercial building space. We've just done that with residential in 2022, albeit it's taken a while for the implementation to flow through. So for NCC 2025, we're back to commercial. And whilst I think it's not necessarily being described as a big step change, there are some pretty significant changes in the public comment draft that are really seeking to maximise the ability to, go for energy efficiency improvements, but there are also elements around on-site solar, EV charging. There's lots that we can potentially unpack here. But just to give us a little bit of guidance on how much to focus on presentation versus Q&A, can I just get a hand raised from people in the room? How many of you have looked or read to some extent the public comment draft? All right, I think we're doing the briefing. Okay. How many of you have used JV1, the neighbours method, to do compliance? What we expected. And how many of you are using the neighbours modelling protocols in JV3? Okay.
How many of you knew you could use the neighbours modelling protocols in JV3?
A few more. Okay. All right. In that case, I think Erica's going to walk us through a summary of the changes, and we still do want to leave time for questions. So if you're online, please submit them via the app. I can see them come through here. And in the room, we want to leave some time. If you've got something you're really jumping out of your skin to ask while Erica's on a slide, maybe stick your hand up, and if she likes, we can go to you as we go through. Okay? All right, over to you, Erica.
Thanks, Frankie. And I'm going to stand up, even though it's late in the day on a Friday and we're all tired and we probably all want to be a bit informal, but maybe standing up will encourage me to get through it more quickly so that we can get on to the Q&A. Also, I just want to say a big thank you to Neighbours for having us today, because without your support from the Neighbours team, Mike and I would not have been able to attend to present to you today. And thank you for everybody who's been involved already in the development of the public comment draft so far, because we've been working on it for about 18 months and there's been input from technical reference groups, there's been input from the Building Codes Committee, and of course we've had our board and our steering committees, and there's actually a lot of people here at this conference who've already contributed to where we are. So, and not least Mike, who's co-presenting with me today. So thank you. So I'm going to just quickly walk you through the changes now, since not everybody has read them, and also an acknowledgement, welcome to country, and acknowledgements of country have already been done, but acknowledging that we are on traditional, on Eora land, and acknowledging the traditional owners of this nation. Mike and I are both from Ngunnawal country in Canberra. So there's a lot of changes that are proposed in the NCC 2025 public comment draft. Our focus this afternoon is going to be on energy efficiency, but I wanted to make you aware that there's a broader suite of changes that have been proposed. We have produced a lot of support materials in relation to all of these changes, including webinars and fact sheets, So go and have a look at the website that's listed on this slide, abcb.gov.au/PCD. That's where you can find all of that material, and there's also links through to the page where you can formally submit your comments. So, with that, I'm going to now be focusing on the energy efficiency provisions for the rest of today's short presentation before we get to Q&A. So to start off with, I'd like to talk about the performance requirements, which are the mandatory elements of the code. So that's why I'm starting there. So we have proposed changes to J1P1 and J1P4, which are relating to commercial buildings and common areas of Class 2 buildings. So for J1P1, we proposed, as you'll see, roughly halving the energy intensity target that's set. So it's quite a significant increase in stringency overall. The other thing that we've done with J1P1 is that we've actually also included for the first time explicitly greenhouse gas emissions targets. So it's not just an energy efficiency target now, it's about greenhouse gas emissions as well. And that's reflecting that with our proposal, we're not only looking at energy efficiency, but we're also looking to build in on-site renewable energy generation as a mandatory element. So at the high level, this is what ultimately, this is one of the things that commercial buildings have to comply with. The other performance requirement for commercial buildings is J1P4. And for J1P4, we've made a couple of changes. So I'm going to start with the bottom one, item 2 that you'll see there, because it's probably the biggest or most significant one. We're proposing to require buildings to have EV chargers in the buildings, and the idea with that is to support people who can't charge their car at home for some reason, such as they don't have off-street parking, or maybe they live in a Class 2 apartment building where it's hard to get the owners' corporation to install charging equipment. So what we're looking to do there is basically support the projected rollout of EVs that's already happening and projected to continue over the coming years. And that's what our provision is about in item 2 there that you'll see on the slide. The other thing that we're doing is that we've modified the requirement relating to future renewable energy, that's in item 1A. And we've just modified that because we're now, as I said, in J1P1, building in a requirement for on-site renewable energy as part of J1P1, and we've modified J1P4 to say that if you're already maxing out the renewable energy generation capacity of your site on day one, it doesn't really make sense to have to still then make provision for future renewable on-site energy. So that's what that change is about. And in relation to EV charging, 1B there, I should also say for Class 2 apartment buildings, we're actually, in a Class 2 building, we're also seeking to, the performance requirement is to serve the daily driving needs of the building occupants. We'll get to DTS later on. In DTS for Class 2, we actually deemed to satisfy, we haven't proposed changes there. We're still just focusing on the infrastructure provision. So, I just want to very briefly talk about the methodology that we used to set these changes. We've had some consultants who created 11 different archetypes that reflect common forms and technologies that are used in commercial buildings, and we basically looked at each type of change individually and looked at how far we could take it in those archetypes and still get a positive cost benefit. We also listened to the feedback that we've had from industry about their experiences using the NCC 2019. So that's the overall process that we use. We started at that building level, but we've worked it up to a whole economy scale using a CRIS, and as David said earlier on, it's a real page turner. So this is what the archetypes look like. This is just an example. The one on the left is the small hospital or aged care. The one on the right is the large office building, and using an energy modelling package, this is how we tested the costs and benefits from each proposed measure. So I'm going to just have a look at what the key changes actually were. So as you probably mostly know already, there's various ways to show compliance with the MCC. Obviously those performance requirements are the mandatory element, but we have different ways that you can show that you can meet them. And one of them is with the verification methods. And we have proposed some changes to some of those verification methods. So starting with J1V1, which is actually the neighbours verification method aligned with the neighbours tool. So as you would have seen already with those performance requirements, and you'll see again in a few minutes with the DTS, we've got quite a substantial increase in stringency. So all the star rating targets and all the energy targets have been raised to align with that stringency increase. And I should say, in terms of what we're targeting, this is really important, overall what we're targeting with our stringency increase is least cost, net zero, carbon ready buildings. So it's we're doing that through energy efficiency, on-site renewables, and in buildings that use gas for their services, provisions to make it easy to electrify that building in future, should the future owners or occupants of the building wish to do so. So as you'll see there, we've had a substantial increase in all of our targets. The other thing with J1V1, the neighbours method, and this does also sort of similar for J1V3, which I'll get to in a minute. We're changing the way that we're asking people to assess, we're proposing to change the way that we're asking people to assess thermal comfort. There are some issues with the applicability of the predicted mean vote approach. So we've proposed using a simple temperature metric requirement. You can still use predicted mean vote though in class 5 buildings, which is where we know class 5 office buildings, we know that the predicted mean vote works really well in that space. And there's an extract from the code there which shows how that temperature requirement will work, simply maintaining the temperature in the modelled space within a specified range, and in order to do that, still not exceeding your emissions, your energy and emissions targets. So the other thing, the few other changes that we've made, you would need to install, in your reference building, you will need to install PV sorry, I should say in relation to specification 33 for J1V1, these are the schedules that set out the additional requirements that you have to do, I guess, above and beyond the modelling process that happens with neighbours and the commitment agreement. So we've said there, you'll need to install the rooftop PV just as it's specified in the DTS. And if the building does use gas, you'll need to comply with those provisions that make it easier to electrify the building in future. And I'll walk through what those provisions look like in a minute or two. The other thing to note is that J1V1 verification method, it only shows compliance with performance requirement J1P1. So in relation to, in particular in relation to electric vehicles, you would still need to do something else to show that you're complying with that aspect of the code. So let's have a look now at J1V3, which is I guess the much more widely used verification method that is based on simulation. And I think probably most of you, if you're working with neighbours as a commitment agreement assessor, you're probably working with J1V3 as well, because I noticed only one person put up their hand when they said, have you used J1V1 to show compliance? So in terms of the J1V3, some of the big changes is that we're asking people to use a future climate file. That's going to, so those files have been published by CSIRO, and I've put a link there to where you could get a future climate file. We haven't specifically said you have to use the CSIRO one, but that file that's been published there does meet those requirements. And it's done under, I guess, a fairly pessimistic climate change scenario of RCP 8.5 pathway. So it's probably going to sort of place more importance on the cooling technologies and cooling energy use in the building. The other change that we've made to J1V3 is that we've removed the ability of people to offset the performance of their envelope by putting PV. So there's a sort of a little loophole, well, it has been described as a loophole in the code at the moment, that you can put PV into your model and use that to degrade the performance of your envelope. Well, it certainly doesn't make sense to have that in place anymore, especially because we're requiring PV on site as part of the reference building, as part of the DTS, and in line with our new, more stringent proposed performance requirements. So that would be a significant change. I think the other thing that is really important for people who are using J1V3 to know is that we're proposing to introduce a 10% margin between the proposed building and the reference building. So at the moment, if your proposed building is just 1 gram of CO2 per year better than your reference building, that's fine, you've passed. But the other the other simulation-based verification methods require or implicitly require a margin. So if
Sorry, it's facade and services, not facade only.
Yeah, okay. So we've proposed to introduce this margin for J1V3, and what Mike is saying is the margin is only applying where you're using J1V3 to show compliance with the whole of the facade and services requirements, because we think actually a lot of that margin is probably available in the services rather than so much in the facade, because our new DTS facade provisions are kind of going to be quite tight. And the other thing we've done is, just like I already mentioned for J1V1, we've proposed changes to the thermal comfort assessment using a room temperature metric similar to what we proposed for J1V1, or a load-based metric where you'd be comparing the loads in your reference building with the loads in the proposed building on a kind of individual zone basis. So, there's a number of other changes. I don't think I've got really limited time, so I'm probably not going to talk through them all now in terms of the simulation-based methods, but I would encourage you to go and read the public comment draft if you haven't already. You've got until the 1st of July to submit a comment, basically tightening up some aspects of that modelling.
And for JV3 especially, you need to read the code itself. In terms of there are other supporting materials and documentation about how we develop the DTS, but for the JV3 and J1V1 modelling, it's really going into the code and looking at the modelling parameters and giving us your feedback on those as they are written.
Yeah. So the intention here is either to clarify, with a lot of these particular ones here now that are on this screen, the intention is either to clarify or reduce opportunities for gaming, or just correct it. I mean, some of the schedules, operating schedules, didn't really match how people are likely to use the space. So some of those kinds of changes as well. So now I'm going to talk about the DTS. And actually DTS is kind of at the basis of all of this, because you feed a DTS building into your modelling process to use it as the reference building if you're using J1V3, and actually the changes to the performance requirements have also been built up out of the analysis that we did from DTS to see how far you could go. So there's quite, there is a raft of changes in the DTS. Firstly, we're proposing tighter solar admittance for the wall glazing facades. So you can see that in these values, the lower targets that are shown in green. This is just an extract from the public comment draft. They're the new proposed solar admittance changes. So that'll be taking into account solar admittance. It's taking into account solar heat gain, shading, window to wall ratios, all those kind of things go into the solar admittance calculation. So it would be encouraging better performing, better shaded windows, better design. We also have somewhat tighter U values that have been proposed for wall glazing, so better insulation. The changes aren't that big in some of the building classes and climate zones. it's more, probably the solar emittance ones are more significant, I think. Now, also while we're talking about building fabric, we've made a clarification to where the envelope sits, which is basically the boundary between the conditioned space and everything else. So there was a requirement that's being interpreted in a way at the moment that is making people put insulation between spaces, or people are, I guess, interpreting it to put insulation between spaces that are going to sit at a very similar temperature for operational reasons or due to the nature of the space. So we've tried to clarify it so that people will not be putting insulation in between those types of spaces where there's no benefit. So that should actually lead to a cost saving, but no decrease in performance, because it wasn't doing any good in those spaces if the two adjacent areas had the same temperature anyway. So for example, near lift shafts and for example between an office and the toilet space adjacent to it. And there's this screenshot is actually from a worked example that's been published by DQ. So David Atkins mentioned it this morning when he was presenting. If you go to the DQ website, they've published 5 worked examples for us that step through the provisions of the code, help to explain the intentions a bit more. Hopefully that will be quite helpful for you so that you can have a look at it and submit informed public comments. The other thing in regards to envelope is we've included provisions within the DTS for vertical shading. So this will mean you can kind of recognise the benefit of the vertical shading without being forced into a performance solution or a simulation-based solution. We can take I think there was very limited ways to take vertical shading into account in the DTS previously, but we've expanded that. We have
to pile it on.
All right.
What's absolutely essential for you to get across in the next few minutes?
Well, I think probably the number one thing is to actually go and have a look at the public comment draft if you haven't already done it. As you can see, we have made some changes to the fabric provisions in J4. All of these things, all of this is still relating to fabric, so solar reflectance index for the roof. We've also made changes in relation to the HVAC provisions. One of the key ones, because we're aiming for that least cost net zero carbon ready, is for buildings to be able to be ready to electrify in future. So while the code doesn't require buildings to go all electric from day one, you can still do gas and you can still do gas within the DTS. If you do gas within your building for your space heating or for your domestic hot water, swimming pool or spa, you will need to make actions to make it easier to retrofit electric heating later on if somebody wants to do it. So that involves leaving space for the electric heating equipment, ensuring that there's sufficient electrical capacity both in the incoming supply, the main switchboard, the risers and distribution boards in the building, and that where the electric heating plant might eventually go, that reserved space has access to the hot water distribution system. Because even though Frankie has pointed out there's lots of different ways to do all electric heating, generally if people are putting a gas plant into their building, it's going to be feeding that heating into a water-based distribution system, and electrifying that distribution system later is going to be really hard if these provisions haven't been made, and it was certainly found to be cost effective to do this.
So essentially, if you were designing for gas for a new building, you also have to do a design for electric. So you need to do 2 designs for your building. You have to make sure you account for the electrical capacity and the space of ripping out that gas and putting that electric in there. So that's a requirement. You have to show how you're going to electrify at time of construction. There's also additional solar requirements to have a look at as well. So
I just don't know why you'd bother, hey? Okay.
no, it's fuel neutral.
Yep.
Yeah.
All right.
Which comes back to our policy authority, actually. And the other thing I'd like to point out is that, and I did already mention it, that there's mandatory requirements for on-site renewables as part of the proposal. So this is the first time that we've had that in section J. Well, if it gets adopted, it'll be the first time that we've had it. There's two different ways that you can specify the on-site renewables in the DTS. One of them is basically to max out your roof space with PV, and that's the sort of the first item in that list. Oh, sorry, this is actually the second item in that list there on the slide. We think most buildings will do it that way, because the other way is a watts per metre squared of conditioned space. But if you have a small roof area and a big conditioned space, that's just not actually going to be achievable. So that's why we've put the item that's limited by roof area as an alternative pathway. But overall, these provisions around PV were designed to maximise the amount of PV that you would use on site. The analysis shows commercial buildings have a really well lined up time with between when they're pulling a load and when the PV is available. So it's very cost effective to use the PV on site, and this is, I guess, a big reason why we've got such a positive result showing in our economic analysis for stringency. Well, stringency 3, the most ambitious stringency level that we investigated various ones, but this is part of the most ambitious one. This is part of what's in the public comment draft, and our economic analysis showed nationally a $17 billion economic benefit from doing this.
There's plenty of questions online, so I'll start one. We're going to do a rapid fire thing, right? I'm going to fire one at you and you've got 30 seconds to answer it, okay? Are there intentions to include embodied carbon requirements into section J? And if so, are there plans to include performance verification pathway using neighbours, kind of like J1V1?
Yeah, yes and yes. It's not in the public comment draft as it's written at the moment, but we're definitely in conversation with neighbours about including that. There would be a plan to also include other pathways for embodied carbon in the National Construction Code going forward.
Great. What kind of provisions are being made to help the buildings have features that make them climate resilient by protecting them from the climate risks of drought and flood? If you've got questions in the room, now's the time to raise your hand.
Better envelopes is one of those. In the code as well, there are also provisions around bushfire protection. That's in another section of the code that's in part effort around fire safety. So whether these refuges or prevention of embers getting in. There's also references to Australian standards to do with cyclones, so that they're changing. So if you have things attached to buildings like solar panels, for example, they need to be able to be cyclone proof. But the main thing that from an energy efficiency perspective is by better envelopes. That's really the key thing that we have, and the use of future climate files in your modelling processes, so that that building will reflect the climate it's going to exist in.
Yeah. And we didn't touch on future climate files so much.
I did mention future climate files. Yep. But I just want to also say that work on resilience against other kinds of, I guess, threats that we're going to face in the future, or we're already facing right now, that's also ongoing work. So this draft isn't, it's not pack up, job done, go home. There's other work, other work happening.
There's a question that goes to that. I'm going to go to Steve first.
Hi, look, I'm just a simple engineer. Everyone is telling us the future is all electric. If all the buildings of the future are going to be all electric, why are we even allowing gas into the next revision?
Just a really simple answer is policy authority on our behalf. So the deemed to satisfy provisions reflect, I think, that the most cost-effective way to get to a carbon-ready building is going to be all electric. If you install gas, then there are significant things that you need to do. But there's simply, when we came down to it, the performance requirement is written as a energy and as a carbon emission. So if you wanted to build an all carbon powered building, a green hydrogen powered building, you could under this. So it has that ultimate flexibility. But when it comes to Erica and I were given an envelope of what we could and couldn't do. And so we have pushed that envelope as far as we can, both literally and metaphorically.
Nice. Any others in the room? Come on, there's more of you. Someone's got to have a question.
talking.
Here we go.
I thank you so much for
Oh,
all the updates.
microphone's coming your way.
I thank you so much for all the updates. I'm wondering about condensation.
We do have proposed updates on condensation management as well. So I would encourage you to go onto our public comment draft website, but there'll be provisions around, for example, ventilated wall cavities in some of the climate zones, looking at improving or reducing condensation risk through those actions.
Most of the condensation ones are focused on residential buildings, so
Yeah.
class 3s and class 9s. Commercial buildings, for the most part, it's less of an issue because of the mechanical ventilation.
Kenny?
Just on the first slide, you had for class 5 buildings, I think 6.6 star for neighbours. Is that the neighbours' performance level? That seems, I think a lot of people would be quite shocked like that. That new provision, because I mean the scale really only goes up to 6. So what's the go there? I suppose, for want of a better word.
Okay, so firstly, that's the numbers that when we consult with neighbours, they ask us to put in the code. So, so there's one direction there. But it also reflects the performance requirement. So the J1P1 performance requirement is near net zero. So we're looking at the kilojoules per square metre of hour of operation and grams of CO2 produced from that. So they're net targets, as Eric has said, but it's a really tight performance requirement, and that's the neighbours level that it's reflective of. I think there's a question online which goes to, are these consistent with net zero in 2050? And from the research that I've seen, I think Climate Works have done some work recently, and others basically said that new buildings have to be essentially net zero by 2030. And so this code's coming in 2025. We have another iteration which will hopefully be focused on residential buildings for 2028. And we're quite close to net zero. A version of net zero, which is the net part of operational energy, that's in the NCC. So I do think that these provisions are consistent with a net zero by 2050, which is the overarching policy that we're seeking to meet. But yeah, it's quite stringent, but it's doable. I mean, simple engineers will tell you that when you're building from the ground up, you can do it.
All right, I reckon we can take maybe one more at the back.
Hi, thanks. Adam from CTEC. Building envelope, are there any ramping up, or what's the philosophy around air tightness and air permeability?
We haven't actually made changes to part J5 in terms of the stringency. We've made clarifications there. There's also no changes proposed in relation to J1V4, the verification method that relates to air tightness testing. However, I guess if building a more airtight building is going to help you get to your performance requirement, then of course there's the option for people to make improvements that way, but it's not. We haven't made stringency changes other than clarifications in the DTS.
Yeah, so there's an option in JB3 that if you can verify your result with a blower door test, you can specify a lower air change, but you have to then also make sure that you're hitting that mark. And if you're going to get a benefit from that, you can use that in the verification process. But the code does not set any permeability requirements. It has some assumptions behind it, but there is no requirement for air tightness in the National Construction Code for residential or commercial buildings.
Okay. I'm needing to wrap up. Is it like a 5-second question, mate? All right, I'm going to give it to you. Don't disappoint.
Yeah, sorry. My question is, in maximizing the solar on the roof, right? Does it mean that we're not allowed to design for accessible roof space?
No, you are allowed to have accessible roof space. So it's maximising the solar in available areas of the roof. So if the roof is being used for plant or for a roof garden or for access for maintenance, for example, and there's a list. I probably... Oh, it's on the screen right now. Great. Thank you.
Here's one that you said earlier.
I was going to say, I would have got to it if there had been more time.
Yep. All right, that was a whistle-stop tour. I want to thank Erica and Mike. They have been touring the country talking about this. I'm sure they probably could have done this in their sleep, but it's really important that, you know, as many of you as possible provide your views into the public comment draft process. So I know, you know, it's a bit of a punish to read a lot of detailed stuff, but they need to hear from you. So please do make a bit of time to put a submission in, and I think you'd both be very happy to take questions or speak to anyone offline. So please just attack one of them in the break if you had any other questions we didn't get to. Could you please put your hands together for Eric?